So far we've taken a look at some of the tools and methods for evaluating projects and a series of cash flows. So what I want to do now is sort of bring some of these together in just a series of different examples. You are unlikely to sort of see this in a final exam, but it might be in a mid-semester or a quiz or something quite small and early on in the course. But the principles that are shown in these examples will still be used throughout the course in things like capital budgeting, so they're still important to know. So what we're going to be taking a look at is using some of the tools and methods that we've discussed previously to evaluate single projects and also compare projects. So our first example is we want to evaluate the following power plant when the MAR, or the minimal acceptable rate of return, or the company cost of capital, is 12%. So we have the following pieces of information here. So we've got an investment cost, we've got a useful life, we've got a market value at the end of the 15 years, and we've got annual expenses and annual revenues, and we've got overhaul costs at the end of year 5 and the end of year 10. So what I find easier to do is sometimes just to draw up a cash flow diagram, and then we can clearly see some of the relationships between the cash flows and sort of check off what we've done each time. So you can see here is that we've got a $13,000 investment in year 0, and we've got an overhaul in year 5 and year 10, and we've got a constant annuity of the profit each year, which is simply just the 1,800 less the 1,000 up here. So that's an $800 annuity, and we've got the $3,000 at the end of 15 years, which is our market value. Now, just remember to have these on the right side of your cash flow diagram, whether it's positive or negative. So this represents cash coming in and this represents cash going out. And that'll be important when you're determining your present worth or your net present value of a project. So then just evaluating this, we've got the $13,000 outflow in year 0, so that's already in terms of present worth. We've got a single cash flow of $200 that needs to be discounted 5 years, and then a single cash flow of $550 that needs to be discounted by 10 years, and a single cash flow of $3,000 that needs to be discounted 15 years. So there's no other way to do these. They're just single cash flows with no relationship to anything else. But what we do have then is an $800 annuity in each of the years from year 1 to year 15. So we have 15 years worth of this $800 with a discount rate of 12%. So what we get is that we have a net present value of negative $7,000. So it's very much not a profitable power plant, and we should therefore reject the project. So looking now at our second example, what we've got is 2 different projects. Now, the thing that's sort of different about this question is that they are the same projects. We've just deferred one 4 years. And so what we need to work out now is that whether it's worthwhile us deferring it 4 years. Now, if you just sort of think about this, whatever your present worth is going to be here, it's going to be the same present worth of this but in year 3. Because if this was 1, 2, 3, 4, 5, 6 and this was 0, it's the same question. But this is now going to be in year 3. So we can basically take the present worth of A and discount it another 3 years to work out the present worth of project B. So we already know that project B is going to have a lower present worth than project A. But simply looking at the cash flows, we've got a $1,000 investment and then a $300 annuity for the next 6 years. And this could be done in two ways. As I said, we can just take this whole present worth and discount it 3 years. Or if you didn't recognize that fact, you could discount the $1,000 4 years and then do a deferred annuity. So figure out the annuity of this and you'd get the present worth here or up here, and then discount that 4 years. So there's two different ways of doing it. I'll do the first. So with a MAR of 10%, we've got the first, which is just a $1,000 outlay in year 0 and a $300 annuity for 6 years. So we get a present worth of $306.58. So then on project B, as I said, because project B is simply project A deferred 4 years, what we can do is you will get, if you take this present worth, that would be at the end of year 3. So then discounting this 3 years at 10%, we get $230.34. So if we had to choose between these projects, we would choose project A because it has a higher project present worth than project B. I'll take a look at our third example. It's a bit more complicated, so I'll take a look at that in part 2.